Hello and welcome back. My name is Amir and this is Project Euler series, puzzle number 12 for today. So let's see the puzzle and start coding then. Highly divisible triangular number. The sequence of triangle numbers is generated by adding the natural numbers. So the seventh triangle number would be 1, 2, 3, 4, 5, 6, and 7, which is 28. The first 10 terms would be like this. This is the triangle number for 1, triangle number for 2, for 3, and so on. If we list the factors of these 7 numbers, we get to these. We can see that 28, which is the triangle number for 7, would have over 5 divisors. So it has like 6 divisors, right? What is the value of the first triangle numbers to have over 500 divisors? Okay, so the first thing is that the triangle number for any number, like 4, is 4 plus 3 plus 2 plus 1. Or there is another formula, and we can, instead of just adding these numbers together, say that is equal to 4 times 4 plus 1, which is 5, and then divided by 2. So this would make our life much more easier. So instead of going in a for loop from 4 to 1, and for bigger numbers from, I don't know, from 1 million to 1, we can just have 1 million times 1 million plus 1 divided by 2. So this is first point. The second point is that for each number, we need to get the triangle number for that one, and then check the number of divisors for that triangle number, and if that is bigger than 500, then we are done. Otherwise, we would go to the next number and do the same process. So it will be an infinite loop because we don't know when to stop. And yeah, so let's write the code for these. I would start with let's start with 500, because the divisors of 500 times 501 divided by 2 will not be, of course, 500. It would be way less. Then I need to save and this function is where we count the number of divisors. But how do we do that? Like, for example, if I have a number like let's say 42, then I don't need to count from 1 to 42 and divide 42 by all of those. The only thing I need to do is go from 1 to the square root of this number, which is like 6 and something. So I would need to go to these numbers and check these numbers. And if 42 is divisible by any of these numbers, then the number of divisors of this will be added to 2. So for example, the number of divisors is 0, then 42 divided by 1 is divisible, so the number of divisors will be 2. 42 is divisible by 2, so the number will become 4. It's divisible by 3, so it will become 6. Not divisible by 4, not divisible by 5, but with 6, so it will become 8. And that is all for the divisors of 42. So let's write the number of divisors then. The only thing I added here is this one, and this is for the perfect squares. So for example, if I have a number like, let's say 49, then I would go 1, 2, 3, 4, 5, and 6, because the square root is 7 and we are going to 1 before that. And I will count the divisors for this one, which is 49 divisible only by 1 in this term, so it will be 2. But I need to include 7 as well. So that's the thing that is doing here. So if n, which is 7, times 7 equals n, then we need to add one more to the count. So it will be 3 instead of 2. So I think this is about this puzzle. So let's run it. So yeah, I hope you liked this video. Thank you for watching, and please don't forget to subscribe, like, and comment my video. See you with the next video.